watching Learn in My Way, and today I have a good news for you. We have decided that we have to make videos on previous year's questions of IIT JAM physics so that you don't have to solve any other book for as previous year's questions. So let us today start from previous year's question 2005. So this is our topic, that IIT JAM physics previous year question 2005. Okay, let us start. Question 1. A solid sphere of mass m and radius a is rolling with a linear speed v on a flat surface without slipping. The magnitude of the angular momentum of the sphere with respect to a point along the path of the sphere of the surface is. Here is the options. Option A, 2 by 5 MAV. Option B, 7 by 5 MAV. Option C, MAV. Option D, 3 by 2 MAV. So let us check the answer. Okay, first consider a solid sphere of mass m and radius a which is rolling with a linear speed v. Let us consider a point P on the surface. Then the angular momentum of the sphere about the point P can be written as LP equals to LCM plus R cross MP, where LCM equals to angular momentum of the sphere about CM. CM means center of mass, and R equals to position vector of the center of the sphere with respect to point P. So therefore modulus of LP equals to modulus of LM, because we just want the value, not the direction. So modulus of LP equals to modulus of LM plus modulus of R cross MB, that is equals to L omega plus MBR, where I equals to 2 by 5 MA square. Okay, and I is the moment of inertia of the solid sphere about center of mass. Let us consider the point P at the point of the constant. We can write R equals to A. So therefore LP equals to 2 by 5 MA square cross V by A plus MVA, where omega equals to V by A. We know that angular velocity is omega. So 2 by 5 MVA plus MVA, that is equals to 7 by 5 MVA. Next question, question number 2. The susceptibility of a diamagnetic material is. Option A, positive and proportional to temperature. Option B, negative and inversely proportional to temperature. Option C, negative and independent of temperature. Or option D, positive and inversely proportional to temperature. Now say, materials for which magnetic susceptibility is small and negative are called diamagnetic materials. In such materials, the individual magnetic moments of the various atoms tend to cancel out completely. So, in the normal state, the atoms of such substances have no magnetic moment. Examples are bismuth, copper, lead, sodium, etc. So, the magnetic susceptibility for such materials are independent of temperature. That means the option C is the correct answer, because the magnetic susceptibility is negative for diamagnetic materials, and it is the property of diamagnetic materials, and it is also independent of temperature. Let us see the next question. Question number 3. The molar specific heat of a gas as given from the kinetic theory is 5 by 2 R. If it is not specified whether it is Cp or Cv, one could conclude that the molecules of the gas are definitely monoatomic, B are definitely rigid diatomic, C are definitely non-rigid diatomic, or option D can be monoatomic or rigid diatomic. So let us see how we can solve this. First, as we know that for the monoatomic gas, Cv equals to 3 by 2 R. So Cp equals to Cv plus R equals to 3 by 2 R plus R equals to 5 by 2 R. And for diatomic gas, Cv equals to 5 by 2 R and Cp equals to Cb plus R, that is 5 by 2 R plus R equals to 7 by 2 R. Thus, we can conclude that the materials of the gas can be monoatomic or diatomic, having no vibrations. So, option D is the correct answer. Next question number 4. The value of entropy at absolute zero of temperature would be option A 0 for all the materials, option B finite for all the materials, option C 0 for some materials and non-zero for others, or option D unpredictable for any material. Now see, entropy. What is entropy? First, you have to know entropy measures the degree of randomness of constituents of a system. At absolute zero of temperature, all molecular motion ceases. Thus, we can say that entropy of the system is zero. That means entropy is the disturbance of any gases or any type of metals. So in that case, if the temperature will be absolute zero, then all the particles are at the static point. So at the static point, the motions will be ceases, so that the entropy will be zero. So option A is the correct answer. Next question number 5. It is few large, but it is not so difficult. Consider a beam of light of wavelength lambda incident on a system of a polarizer and an analyzer. The analyzer is oriented at 45 degrees to the polarizer. When an optical component is introduced between them, the output intensity becomes zero. Light is incident normally on all components. The optical component is option A full wave plate, option B a half wave plate, option C a quarter wave plate, or option D an ordinary glass plate. So the answer is option C. How it will be possible that the answer is option C? Let us check. See, according to the Malus law, I equals to I naught cos square phi. So where phi is the angle between the axis of analyzer and polarizer. See here, one is analyzer and one is polarizer, and you don't have to get a problem that what is analyzer and what is polarizer, because you can choose anyone as analyzer and other one is the polarizer. So intensity of light obtained through the component I equals to I naught cos square 2 phi equals to 0. So cos phi equals to 0, so that phi equals to pi by 2, where phi is phase introduced due to component which is pi by 2. This value of phase is equivalent to the path difference of lambda by 4. Thus the introduced component is a quarter wave plate. I think you understand that. If you don't understand, please write it on the comment box, so that we'll make a separate video to understand this. So that's all for this video. If you understand the questions, please share with your friends. Don't be so much selfish that I will be prepared for IIT JAM. My friend should, if my friend will see this video, then the competition will be very much high. Don't do that. This is called selfishness. Don't do that, okay? So share with your friends, and please subscribe this channel for more educational videos, for more IIT JAM videos, and also for more videos regarding to mathematics or regarding to computer science and so on. Okay, this is over now. Till then, bye bye and take care.